Physics exam. Okay, it was your physics exam. Okay. I thought chemistry tha. When is chemistry? Is on 16th. Achha. Okay, fine. It is on 16th. So you can see the screen, yes or no? Chaliye. I'm giving you a few minutes. Do these questions. So what else this we are done with? Wait a second. Isomers, structural isomers, structure and bonding, conformers. Okay. Okay. I need the answer for at least one of these questions in 2 minutes. Okay. तीन सवाल दिया था आप लोगों को, है ना? आप लोगों को कर लेना चाहिए था. किसी को हो रहा है? किसी से हो रहा है अभी? देखते हैं 2 मिनट है ना. You guys have 2 minutes. Just look at one of the question. All of these questions are similar only. जो भी एक आपसे हो जाए, थोड़ा सा भी हो गया देन आपको याद है. See, raise your hand if you were able to do any one of them. Or a part of any one of them. Raise your hand now. Or you are about to get the answer for any one of them. Raise your hand. Even if you started doing the question, even if you understand what will be the product, raise your hand. Yes, Atif, can you please turn the mic on? Yes, Atif, are you there? Seems no. What about Reba, Surat? Reba, are you there? Can you turn the mic on? Yes. Okay. So what happened, Reba? You can't do the first question, A1, A part. I can't hear you, Reba. I can't hear you. Can you please rejoin? I can't hear you. What about you, Surat?
Yes, sir.
Yes. Were you able to do the first one? Tell me. Do you know what to do, what not to do? Surat, can you please reply? I gave you a few times, few minutes. Na, you can. I still can't hear you, Reba. By the way, yes, Surat. Surat, your mic is off. Can you please turn the mic on and tell me how will you do this first question? Did you complete the notes, Surat? Surat, did you complete the notes? How many of you completed the notes now? From Monday, this one. How many of you completed this? Please raise your hand. No one. Wow. That's very disappointing, guys. How will you write the exam? How will you prepare for exam if you're not writing the notes? And organic chemistry, I have said not once, like many times, you have to keep in touch with organic chemistry. Otherwise, you will not understand even an iota of organic chemistry if you don't write the notes. I will not send you right now, Reba. हम बाद में भेजेंगे class के end में. Okay. Now, if you don't have the notes, then you will you ask Nishkar sir. क्या ही फायदा फिर बताइए? Like if you are not doing homework, not completing the notes, just being here for 2 hours and then just leaving. Like you have a few weeks left. Please concentrate, na. Please focus. थोड़ा सा ही time बाकी है. After that you have exams, then again you will get new class. Okay. There are a few weeks left. These are important chapters. यहाँ से सवाल आएंगे and these are easy chapters if you just read them. You don't have to solve. You don't have to solve numericals. Can you understand that? You don't have to solve numericals. Maths नहीं है अच्छा, तब आपको यही chapters हैं. Otherwise, equilibrium, thermodynamics, both are large chapters. Even states of matter. These three are big chapters which are completely numerical. है ना? उसमें numerical ही आएंगे. In these chapters, you will not be getting numericals. So please take the advantage. यहाँ पे सिर्फ आपको पढ़ना है. You only have to read here. You don't even have to pick up the pen. Okay, yeah. Sometimes you will have to pick up the pen to write the answers and all, but in general, you will have to read. If you just keep on reading, you will not forget and you will do well in organic chemistry. So this is going to be your homework. I will not be explaining this. जिसको lecture देखना वापस से वो lecture देखें. I spent a lot of time in these type of questions when I was explaining the formation of alkenes and the reactivity of alkenes. Where was that? So see, I started this from here. Halogenation reaction. This is the reaction that I'm talking about. And see how much we explained it and how much we did a lot of questions also. Hai explained each and every term. I explained you the point of attachment and how to look at different carbon atoms. All of those things are gone on waste because you did not revise it. अभी नहीं आ रहा ना किसी को. अभी तो नहीं आ रहा है किसी को. Then again you will have to spend that many, like half an hour अगर spend करना पड़ेगा. So again you have to spend half an hour to understand what is going to happen in the halogenation of alkanes. So मेरा तो like that half an hour in which we explained on Monday, that is gone completely on waste. है ना? And you did not even complete the notes. Notes complete करते तो थोड़ा कुछ याद रहता. Please utilize the time when you have it. Okay. आधे घंटे से कुछ एग्जाम में फर्क नहीं पड़ने वाला है. और like UT and pre-board, you are not, these marks, they are not going to get added in your final examination. उस पे आप लोग इतना ज्यादा ध्यान दे रहे हैं. Keep revising guys. Like काम जो है उसको तो complete करके रखिए आप लोग. Isomers, so we did structural isomers. Now please listen carefully and answer me when I ask questions. Don't be just sitting like there silently. Okay, please answer me. Okay, so after structural isomers, we will talk about the geometrical isomers. Okay, we're going to talk about the geometrical isomers. So the topic is geometrical isomers. Now, in geometrical isomers, I think we discussed this a bit when we were discussing the organic chemistry. And in organic chemistry, when we were dealing with isomerism, where did we deal with isomerism? Yeah, here we dealt with isomerism, and I think we did stereoisomerism, cis and trans. So cis and trans isomerism in alkene. This is the geometrical isomerism or the stereoisomerism that we are talking about. So in geometrical isomerism, you will write the first point. Let us see. We have carbon double bond carbon. Here we have hydrogen. Here you have CH3, and if you have CH3 here and hydrogen here, and the another molecule is C double bond C, CH3, CH3, and the hydrogens are on these sides. Now the difference is here we have CH3 and CH3, both of these groups, which are bulky groups, they are on the same side, and in this case they are on the different side. In this case, they are on the different side. Now, when I look at the distance here, then these two bulky groups are, they have this distance, and if I talk about the bulky group of CH3, CH3, and the distance here is somewhat larger. The distance here is somewhat larger. So we know that this is the cis form because they are in the same position, and this is the trans form. This is the trans form, and both of these structures, they are not interchangeable. We cannot rotate it. For example, if the bond rotation was allowed in this pi bond, then we would be easily making cis and trans, and we could convert cis to trans isomer very easily, but the bond rotation is not allowed in pi bond. That is why we get two isomerism, two isomers and geometrical isomerism. So due to bond, due to restriction of bond rotation in alkenes, along the double bond, it leads to geometrical isomerism. So here what is same? The connectivity is same because the CH3 groups in the cis form and also in the trans form, they are connected to the carbon atom, which is doubly bonded to another carbon atom. Same as in the cis form, and there is the same connectivity is present in the trans form also, but the position or the relative distance of those groups are different. So connectivity in cis and trans form is same, but the relative distance between groups and atoms are different. And that is why we get cis form and the trans form. So when two identical groups or atoms are attached, when two identical groups or atoms are attached on the same side, of double bond, then it is then it is called cis isomer. Okay, so you have carbon, so you have AA, and here you can have anything B or C. Now, since you have two same groups attached on the same side, even though the other groups they may be different, it doesn't matter. But if you have two same groups or atoms that is attached on the same side of the double bond, it is known as the cis isomers. But when two identical groups or atoms are attached on the opposite side of double bond, then it is called trans isomers. It is called trans isomer. If you'll have carbon double bond carbon, A group is attached here, A group is attached here. So these are the two same groups. So you have to just identify any two same groups or identical atoms or groups, and if they are on the same side, that means अच्छा ये B C नहीं लिखना चाहिए, BD लिख देते हैं, because C it will represent carbon. So let me just write this as D. So if you have two groups on same side, cis, two groups on opposite side, then it is going to be trans. Okay, it is going to be trans. Let us write the question. Identify cis and trans in the following. First of all, identify cis or trans in the following. Tell me, guys, cis or trans? Cis or trans? What happened? किसी जवाब ही नहीं आ रहा. आतिफ, अभिनव, सूरत, दिशान. What happened? Trans. हाँ तो ठीक से बोली जरा ना. You can hear me properly, yes or no?
Yes, sir.
Can you hear me properly? है ना? So you also try to speak in same manner that I can hear you properly. What about this? Cis or trans?
Cis.
Cis. What about this? Cis or trans?
Cis.
What about this? Cis or trans?
I think it's cis.
Yeah, it is cis. Okay, right. So here you have identical groups. You have to just identify. So one type of question you will be getting is to identify the cis or the trans, है ना? Cis or the trans. Here you have this is identical. Okay. Next type of question that you will be getting is which of the following alkenes can show geometrical isomer. Okay, so let me give you a question. If you have a carbon which is bonded to doubly bond carbon atom, and these are attached to hydrogen. Now you tell me, what is this? Is this cis form, trans form? What is this? Cis or trans? अरे कहेगा cis, कहेगा cis, कहेगा trans. There is no form, na? Because let us suppose if you have something like this, C double bond C, and there is A A and let us say hydrogen and hydrogen. Now here I can say that it is transform. Why? Because if I exchange the position of A, if I exchange the position of A and H, then I will be getting the cis form. I will be getting a different element, different compound only. Yes or no? See, both of these are different. Yes or no? Tell me if I exchange this position. Okay. So we are getting cis form, but here if I exchange, there will be no change, right? There will be no change. So that is why this molecule CH2, it will not show any geometrical isomer. Doesn't show. Geometrical isomerism. Achha, geometrical isomerism, stereoisomerism, it is the same thing. Geometrical isomerism is a part of or is a type of stereoisomerism. Okay. So you can also be asked which of the following alkenes can show stereoisomerism. B part. If we have C double bond C, here we have H2 and here we have Cl2. So whenever you get this type of molecule, you will make C double bond C, hydrogen, hydrogen, and then chlorine and chlorine. So tell me guys, will there be any change if I exchange the position of hydrogens? Yes or no? Will there be any change?
No, sir.
No, right? So this will also no GI. Tell me for this molecule. So this carbon has attached with itself chlorine. One chlorine, one hydrogen is attached with this carbon atom, which is doubly bonded to another carbon atom, and this carbon atom has a CH3 group and there is a hydrogen group, only CH3 group. So tell me for this molecule. I'm giving you 2 minutes time. Draw the molecule and tell me in the chat. Will it show yes or no? है ना? Yes, if it will show geometrical isomerism, please draw and tell. अगर किसी ने ऐसे ही बताया ना फिर बताएंगे आपको. Draw and exchange the position and then tell me. Will it show any geometrical isomerism? Yes or no? Okay, I've got an answer from Atif. I've got an answer from Viba. Okay, I'm waiting for others. Surat. Surat, Abhinav, what happened, guys? Reba, you made this structure, yes or no? Reba, you made this structure? Okay. Now let me exchange the position of hydrogen and chlorine. Are they different or are they same? So, will it show geometrical isomerism? तो फिर आपने क्यों लिखा it will show? That means you did not make. Did you make the structure? Yes or no? Tell me, Reba. Write this. Write this CH3. Then this carbon is attached with hydrogen, double bond. You have this carbon which is attached with hydrogen, and then there is a Cl molecule here. So carbon is attached to hydrogen and CH3, carbon is attached to hydrogen and chlorine. Write the structure, then try to exchange, and then tell me whether it will show geometrical isomerism, yes or no. Okay, Atif. Okay, Reba. What about this one? Okay. Atif,
Yes, sir.
it will show, it will not show. What do you think?
It will show, sir.
It will show.
Yes.
Did you write? Did you make the structures?
Yes, sir.
You made these structures. Both these structures.
Sorry, sir.
If it will show geometrical isomer, then you will have a cis isomer and you will have a trans isomer, correct?
Yes, sir.
Do you have both these structures with you, cis and trans?
Yes, sir.
Okay. So I'm going to exchange these two. You have one of these structure will be this one, yeah? I know. This will be one of the structure, right? Huh? Atif?
Oh, sorry, that's the fifth question. I thought it was the fourth one.
अरे तो ये तो नहीं शो करेगा, वो तो आपने लिख ही दिया चैट में, ई के बारे में पूछ रहे थे हम.
No, sir. Yes, the fifth one not sure. Not sure.
So if any one of the doubly bonded carbon atom is attached to two same group or atom, then it won't show GI. Then it won't show GI. Right, next, preparation of alkenes. You don't have to write preparation of alkenes. And preparation of alkenes, we have the first preparation, that is from alkynes. And we had a taste of this reaction in the preparation of alkenes also. So from alkynes, if you have, let us say R1, it is bonded to a carbon, triple bond carbon, and it is bonded to some R2 group. Okay, so R1 and R2. R1, okay, let me take this as R1 and R2. So this can be anything. Okay, R1 can be hydrogen or CH3 or any of the alkyl group or any of the groups. It can be anything. Now, if you react this with hydrogen in the presence of palladium and charcoal, the catalyst, then you are going to get a cis isomer. Okay, you are going to get a cis isomer. That means the hydrogen will be added on the same side of the double bond. Hydrogen will be added on the same side of the double bond. So hydrogen, and here you will be having the R1 and R2 group. But if the same reaction is done in presence of sodium and liquid ammonia, liquid NH3, then you will get a trans isomer in which the hydrogen will be attached in the opposite side of the double bond, and here you will be having R2 and here you will be having R dash. Is this clear with everyone? Can you remember these two reagents? Hydrogenation of alkynes in the presence of palladium charcoal will give you cis isomer, and in liquid ammonia it is going to give you trans isomer. Let me also tell you the reason. In palladium charcoal, what happens? In palladium charcoal, we have palladium metal. So this palladium metal is there and it attaches itself with hydrogen. So these are the hydrogen which are attached like this. So hydrogen, like palladium charcoal is completely powdered, and if you pass hydrogen gas, so hydrogen is attached on those particles, finely divided particles. Then comes the carbon triple bond carbon. And as you can see, if the carbon triple bond carbon comes, then it is going to attach hydrogen from the same side only, because only from one side it is going to get hydrogen. From this air, it is not going to get any hydrogen. But if I talk about liquid ammonia, in this case, you have a solvent. In this, you have sodium. Sodium atoms, it helps in the formation of alkenes. But in liquid ammonia, you can say that the carbon, it can attach hydrogen from any side. So obviously, it will prefer to attach hydrogen from the trans side, because trans side is more stable, as this R and R group are away from each other, and that is why the repulsion is less. So trans is more stable, and in liquid form, if there is a possibility of making trans form, the alkene will always prefer to make the trans form rather than the cis form. Now in palladium charcoal, the problem is that we don't have any possibility of making a trans form. So that is why cis form of alkenes are made. Okay, so write some questions. Write the major product. Here C2H5. In the presence of palladium charcoal. This will be in the presence, okay, plus H2, okay. In both of them, we are adding H2. H2 in the presence of liquid ammonia. Done? Is guys done? Done guys? नहीं, क्या हो गया? Yes, Atif and Riba, you can't write the product. Ali, can you please answer me? Can you write the product or not? Yes, simple questions I'm asking. आप लोग इतना ज़्यादा time लगा देते हैं इसी में. Yes, Atif. Yes, Atif, you were saying something.
Sir, I finished.
Okay, so बोलिए तो सही. So what about Riba? So in this case, we will be getting cis form. Cis3 will be attached here, and in this case, we will be getting transform. That is C double bond C, hydrogen here, C2H5. The other hydrogen will be here, and here we will be getting CH3. Okay, so these are the two products. Right. Next, the next preparation that we have to see is from alkyl halides. Alkyl halides. That means from RX, from alkyl halides. An important thing to note is that only possible if the alkyl halide has beta hydrogen. That means you will have a carbon, another carbon. This carbon will have X. So this is alpha carbon. This is going to be alpha carbon, which is directly attached to the functional group. That is alpha carbon. And the beta carbon, that is the adjacent carbon, should have a hydrogen atom. And there may be any other groups attached, Now this X, it will be chlorine, bromine, or iodine. So fluoroalkenes or alkyl fluoride, they don't show this reaction because the CF bond is very strong. Now, in the presence of alcoholic KOH, or NaOH, alcoholic NaOH or alcoholic KOH, that means you will have a base. In the presence of base, what happens? The base is going to abstract the hydrogen. So these two will form a bond like this. HX will be eliminated and you will be forming C, double bond C, and the groups attached on the carbon atom, the two groups attached on both of the carbon atoms will be intact as it is, and you will be getting HX. You will be getting HX. Now, as we know, as we can see that the X bond, it is getting broken. The mechanism is something like this. You have carbon, carbon, Here you have hydrogen, here you have halogen group, here you have halogen atom. So initially the OH negative, it attacks on the hydrogen atom. Hydrogen atom shifts the electron towards the carbon-carbon bond. And since this carbon cannot have 5 bond, it breaks the bond from X. So you get carbon, double bond, carbon. And there are these groups attached to the carbon atoms which are doubly bonded. They are intact as it is. Plus you get HBr or HX. Okay, in general HX. So we can see that which bond is getting broken. This bond is getting broken. That is the CX bond. That is the CX bond. Now, if I compare the bond strength, then the CCl bond will be more strong because of effective overlapping of 2p 3p, followed by CBr and followed by CI. That is why if I want to rate the reaction, rate of reaction is what? It is inversely proportional to the bond strength. Because if the bond strength is weak, if the bond is weak, then it is going to break easily. And if it is going to break easily, the reaction will happen. This reaction is going to happen faster. So if the rate of reaction is inversely proportional to bond strength, then I will say that RCl will be fastest. The rate of elimination in RCl will be fastest, followed by RBr. Sorry, this will be inverse now. So we will have RCl will be slowest, followed by RBr, followed by RI. Because RI bond can break very easily. Now, so essentially what happens, you have a carbon, hydrogen, halogen. So when the hydrogen leaves, so essentially it gives the electrons to this carbon atom, and slowly this halogen atom also leaves. So essentially you in between have this type of structure, minus, and there is positive. So this minus positive, here you have electron, here you don't have electron. So they form a bond that is pi bond. So there is, in a sense, a formation of carbocation. There is a formation of carbocation. And due to the formation of carbocation, the rate of reaction, I am now comparing different types of alkyl groups. So 3 degree will be fastest, followed by 2 degree, and followed by 1 degree due to formation of carbocation. So these are the two orders that you have to remember. This is due to the bond strength, and this is for alkyl group. You have alkyl halide. So there can be different types of alkyl, and there can be different types of halides. So we have halides, chlorine, bromine, and iodine. So in chlorine, bromine, and iodine, we have alkyl iodide, which will be very fast because of the very weak bond of Ri, and the rate of reaction will be highest if you have 3 degree alkyl halide, because the 3 degree alkyl halide can easily form carbocation, and that carbocation will be stable. Now the next question comes, if I have something like, let us say CS3 carbon, there is a halogen, let us say Br is present, and then here you have CH2 and CS3, CH2 and CS3. Now in this case, all of you can see that this is our alpha hydrogen, sorry, this is our alpha carbon, and there are 2 beta carbons. This is beta carbon, and this is also beta. Both of these beta carbon have some hydrogen. So this beta carbon also have hydrogen. This beta carbon also has hydrogen. So in both of them, the reaction can happen, and I can say I can form 2 products. Alpha and beta. If this hydrogen and this Br is going to, so let me write 2 products, beta 1 and beta 2. This is beta 1. This is beta 2. Now the reaction, it is happening from beta 1. If the reaction is going to happen from beta 1, then I will be getting CS3 will be intact. I will be getting a bond between CH, double bond, CH and CS3. So Br and H, Br was here, this is alpha carbon. So Br and H, they left, they were eliminated, and I formed a bond between alpha and beta 1. Now in this case, we will form a bond between alpha and beta 2. So that bond will be CH2, double bond, CH, single bond CH2, and CH3. So please tell me if you understand these two products, yes or no. Please tell me if you understand these two
Yes,
products.
sir.
All of you, yes or no? Yes or no, guys?
Yes,
What
sir.
about others? Okay. Now, in this, we have to see which is more stable. Which is more stable. If you remember a bit of hyperconjugation, then in hyperconjugation we said that कहाँ गया आपका hyperconjugation? Okay. So hyperconjugation is applicable in alkenes also. Can you see that? Yes or no? See this? Hyperconjugation is applicable in alkenes also. Right, guys?
Yes.
Anna, we have seen this. So applicable in free radical. It is also applicable in alkenes, and it is also applicable in carbocation. It is also applicable in carbocation. Now you see here, we have discussed the same problem. Compare the stability. Can you see the problem here? Tell me. Can you see the problem? Which is more stable? है ना? ये देखिए आप लोगों ने सेम चीज किया हुआ है, ठीक है? सेम चीज आपका यहीं पे आ रहा है. That is why these things are important. Hyperconjugation. Now you tell me A and B, which is more stable? 1 or 2, which is more stable? बताइए, hyperconjugation से बताइए which is more stable? भूल गया ना? हाँ, what happened, guys? आतिफ, अभिनव, उमर, रीबा, सूरत. इसीलिए ना, रिवाइज डेली. एग्जाम में जब ये चीज होता है ना, देन यू हैव मेजर रिग्रेट्स दैट यू नो सम टर्म्स बट यू डोंट रिमेम्बर प्रॉपर्ली, एंड यू विल नॉट फील that much regret at any point of your life. Like the intensity of that regret is very high because you are like, I have read this, I have spent time on this, but not properly. तो थोड़ा सा और कर लेते ना, वही हो जाता. Like the regret is that अगर थोड़ा सा और कर लेते तो हो जाता. Now in this case we have sp2 hybridized carbon atom. So this is sp2, this is sp2. Okay, now please remember, now we have different molecule at hand. We have different molecule at hand. Usko reactant se please don't treat it, or also don't attach it with the reactant. We have new alpha carbon. So this is the alpha carbon according to, this is the alpha carbon with respect to the sp2 hybridized. This is the alpha carbon with respect to sp2 hybridized carbon atom. And in this case we have this as sp2 and this as sp2. Both of these are sp2. I hope you can at least identify the sp2, and this is the alpha carbon. Now you tell me, how many alpha hydrogens do we have in the first structure? How many alpha hydrogens? How many alpha hydrogens, guys? 6. Very good. What about here? How many alpha hydrogens? 2. Which will be more stable, 1 or 2? Which will be more stable, 1 or 2? 1. Very good. So this will be our major product. So this reaction is happening in the presence of alcoholic KOH or alcoholic NaOH. Okay, so please write in beta elimination of alkyl halide. Beta elimination, why? Because hydrogen is eliminating now. So if hydrogen which is in beta position, in beta elimination of Rx, more substituted alkene is major product. In beta elimination of Rx, more substituted alkene is major product. Okay. So I'm writing the product है ना, एक तो आपको होमवर्क देंगे हम, वो अलग है. Here I'm asking you to identify the major product in following. है ना, देखिए, how many beta hydrogens? This is beta carbon, this is beta carbon, both of them hydrogen has hydrogen, alpha beta. So you'll make two products, है ना, both of these hydrogens are different also, that is why you'll make two products. One is with alpha beta and this is with also alpha beta. So you tell me guys, which is major, which is minor? More substituted देखिए, है ना, try to find the number of alpha hydrogens in both of them. sp2, identify sp2, identify alpha carbon, identify number of alpha hydrogens and tell me which is more stable. Done guys? What happened? You can identify na sp2, alpha carbons, alpha hydrogens, yes or no? Riba, Atif, Surat, Abhinav, guys, please tell me. You can identify na? Yes or no? What happened? Can you say yes or no also? Atif, Aisha, Abhinav, Rishan, Umar, Riba, Rihab, Surat. Can you identify sp2 carbon atoms here? Yes or no? No, you can't identify Riba. What does that? What? Yes, sir. Yeah. You can't identify, or you can identify. Tell me properly, na? Oh God. Can you please write yes sir, I can identify or I can't identify anything, please guys. क्या आप लोग इतना ज्यादा टाइम क्यों लेते हैं ये चीज जवाब देने में? नहीं, आप लोगों से तो बात करके you're not even answering now. From vicinal dihalides. From vicinal dihalides. Now in vicinal dihalides, we just react with zinc Carbon, vicinal means vicinity. In vicinity means in neighborhood. Vicinal means vicinity. Derived from the word vicinity, which means neighborhood. Neighbor or near. So you have two carbon atoms which have halogens, and if I react this with zinc, then there is a double bond formed, and we get alkenes, So for example, if you have CH2, and both of these have Br, here also Br, plus here we get zinc halide. So I treat this with zinc, and we will get CH2 double bond CH2. So for example, if I have two bromines like this, I will react this with zinc and I will get a cyclopentene molecule. Plus I will be getting zinc Br whole twice. Next is bi-acidic dehydration of alcohol. Acidic dehydration of alcohol. So acidic, that means in the presence of acid. Dehydration means removal of water, and alcohols means we are doing all this treatment in alcohol. So we have carbon. Now this alcohol should also have a beta hydrogen. So this H2O, it is very similar to the alkyl halide reaction. Now in the presence of H2SO4 and some heat, we will be getting C double bond C plus H2O, C double bond C plus H2O. Now in this case, we have the rate of reaction will be, for different alkyl halide, rate of reaction is going to be again similarly 3 degree is going to be fastest, followed by 2 degree, followed by 1 degree alcohol, Now you can write the mechanism for this. Initially, we will have CS3, CH2, OH. Now there will be oxygen lone pair, and from H2SO4 we will be getting the hydrogen atom, and this hydrogen atom, it is attached with HSO4 negative, HSO4 only. Now this oxygen will attack on hydrogen, because what hydrogen is acidic, so there will be H plus here essentially, and we will be making CS3, CH2, O, and there will be 2 hydrogen attached to 1 oxygen, and that is why oxygen will get a positive charge. Now we can see that there is a possibility of formation of water molecule. So the water molecule will leave, and we will be getting CS3, CH2 positive. Okay, so we are getting a carbocation. Now when I look at this CH3, this will have 3 hydrogens. Now this hydrogen will be attacked by this electron. It will shift here to minimize the charge, and the hydrogen will be abstracted by the water molecules that are present here. Will be abstracted. So we will be getting CH2 double bond CH2. So here we have a formation of carbocation, and if the formation of carbocation is there, and that is why we will have the reactivity in which 3 degree alcohol will react fastest, followed by 2 degree, and then followed by 1 degree. So if I want to summarize all the formation of alkenes, then I can start with, first of all, C triple bond C, R and R. Okay, so this will give you alkenes. Give me C double bond C. Okay, and I can also have the same reaction. So this is with PD and charcoal, which will give me cis isomer, cis form. And if I have sodium, the presence of liquid ammonia, then it is going to give me trans. It's going to give me transform. Next, if I have, let us say, R CH2 CH2X, then in the presence of alcoholic KOH, alkyl halide, in the presence of alcoholic KOH, it is going to give me C double bond C, alkene. Not going on the specifics, okay? Not going on the specifics. And if I have R CH CH2X, and here also there is X, in the presence of zinc, it is going to give me alkene. It is going to give me alkene. So we have alkyne, alkyl halide, vicinal dihalide, and what else you can have? You can also have R CH2 CH2OH. Now in the presence of an acid such as H2SO4 and some heat, it is going to give me alkyne. It is going to give me alkyne. Now it is very important that I have written CH2 here. That means these are the beta carbons and they should have hydrogen. If they don't have hydrogen, then we will not be getting any alkene. Okay, so these are the general method of preparation for alkenes. These are general method of preparation from alkenes. So to cite some questions. Write the major products. Okay, write the major product. The major product for following. Write these 5 questions. Let me know if you're done. This is your homework. Raise your hand if you're done. Okay. Okay, Reba. Reba, please save this link. This is for the This is for the Monday's class. Okay, that I've shared with you, Reba, right now. Now I'm leaving you guys, but I want the answers for these questions in the next class. No matter what you do, no matter what you do, you ask me all 5 questions from like via Nishkar sir. You said that I have doubt in this question, this question, this question, all 5 questions. Okay, but I need the answers. I'm leaving you guys 45 minutes before. आपके पास टाइम नहीं रहता है, but please do the homework. If you are not doing this, then my complete hours and your hours are going to waste. Okay, अगर आपको notes ही चाहिए तो notes तो है ही, है ना? I can send you notes. अगर आपको सिर्फ notes ही पढ़ना है ये chapters तो, ठीक है?
Sir, when should we
When do you have your next class, Umar? When is your next class? So I will check on Saturday. अभी आपको 45 मिनट दे रहे हैं कि अभी कीजिए और आप लोग बोल रहे हैं कि कब है नेक्स्ट क्लास. Why I am leaving you guys early, huh?